Hello friends, let's solve problems on fair coin and die. Welcome, it's your science tutor. In this video, we shall be taking some problems on coin and die. We have some questions on the board. The first one says, in a single throw of a fair coin, find the probability of getting a head, and B, a tail. In a single throw of a fair coin, like I stated previously, for a fair coin, and I throw a single coin, I'm going to have a head and a tail. So that makes the sample space, which is the total number of possible outcomes, to be 2. A head and a tail, 1, 2. So it simply means n for sample space is equal to 2. That is for a coin, because a coin is having 2 sides, a head and a tail. Now, based on this question, we are told to find the probability of getting a head. So for the first part of the question, A, probability of getting a head, I'm going to be using H to represent the head, is simply out of the 2 outcomes, I have just 1 head. So probability becomes 1 out of the total outcome, which is the sample space. So probability of getting a head is 1:2. That's 1/2, because I have just a single head in a single throw of a fair coin, 1 coin. So probability is 1/2. The second part of the question says probability of getting a tail. Probability of getting a tail, I'm going to be using T to represent a tail. So how many tails do we have when I throw a single coin, a fair coin, once? I have just 1 tail. So 1 out of the 2 outcomes. So the probability becomes 1/2. This is a simple way to analyze problems involving a single coin. Now for a die, the second question says, in a single throw of a fair die, find the probability of getting, we have a set of questions. The first is an odd number, a prime number, a perfect square. Stated in previous video, we know that a die is having 6 faces, 1 to 6, 1, 2, 3, 4, 5, and 6. When counted, it gives us 6 outcomes. So that is to say, the number of possible outcome, which is our sample space, will be equal to 6. Now, for the first question, the probability of getting an odd number will be, out of the sample space, out of the outcomes, I'm going to count the number of odd numbers that are present. So I have odd numbers to be, this is an odd number, 1, 3, and 5. So out of 1, 2, 3, 4, 5, 6, I have 3 odd numbers. So that makes the probability of getting an odd number to be equal to 3 out of 6 outcomes. 3, 1, 2, 3 out of 6 outcomes, which automatically becomes 1/2 when reduced to the lowest term. That is for the first case. The second case, it says probability of getting a prime number. A prime number. I'm going to take my time to explain this in subsequent videos. But in brief, a prime number is a number that is having 2 factors, itself and 1. That's a prime number. So in this case, we are going to be listing the prime numbers that lie between from 1 to 6. 1 is not a prime number, so we have 2. 2 is a prime number. 3 is a prime number, and 5 is also a prime number. So when counted, we have 1, 2, 3, which is 3 out of the sample space 6. And that makes 1/2 when reduced to the lowest term. The third problem, it says the probability of getting a perfect square. All these are terms I'm going to be explaining in due course. The perfect scale. Perfect scale are simply numbers that can be paired together to form another number. For example, for clarity, 1 is a perfect scale because 1 times 1 gives us 1. So 1 twice gives us 1. 1 times 1 is 1. So that makes 1 a perfect scale, two numbers. 4 is a perfect scale. 4 is a perfect scale. Why? Two numbers multiply to give us 4. 2 times 2. Two same numbers gives us 4. That makes 4 a perfect scale. So at the end of the day, we have just two numbers that are perfect scale, and then we have our final result to be 2 out of the sample space 6. When reduced to the lowest term, we have 1 over 3. So this is how to solve simple problems that involves a coin and a fair die. I'm sure this video is helpful to someone out there and we got value. If you're new to this channel, please do well to subscribe, and to my returning subscribers, I will always say thank you for showing up. See you for more problems. Bye for now.